Alright, I've got here the binomial formula, and we're going to use this formula to work out the problem that's illustrated here in your notes. And in this we are being told that we are picking a sample of 15 items out of some population, and we know that 10% of this population is defective in some way. So my p-value here in this formula is equal to 10%, but I have to express that as a decimal, so that's going to be the 0.1. And in the problem, we want to know what's the probability that x is equal to 3. So if I plug these numbers into this formula and see how this would work if I was doing this out by hand, I'm looking for the probability x is equal to 3. And mathematically, a lot of times we simply write that as p of 3. Alright, equals n factorial. Well, n factorial, n in this case is 15. And a factorial, as your notes say, you take the number and you basically multiply it by every number that precedes it. So 15 factorial will be 15 times 14 times 13 times 12, blah, 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 all the way down to times 1. Alright, x in our case is 3, also factorial. And I got to multiply the 3 factorial by n minus x factorial. N, as we see, is 15. X is equal to 3, so 15 minus 3 gets me 12. And on my calculator in a minute, I'm going to use the factorial button. Okay, I'm going to work that out, and then once that's done, we need to multiply it by the proportion of our population with the characteristic of interest. In this case, we know 10% are defective. We got to raise that to the power of x, which in this case is 3, and we're multiplying that by 1 minus p, so 1 minus 0.1 is going to get me 0.9. And I'm raising that to the power of n minus x, and n minus x in this case is equal to 12. Okay, so if I go to my calculator here now, and bring this up, I need to move that out of the way. I need 15 factorial. Now, factorial button on your calculator, depending on what your calculator looks like, is either n with the exclamation mark or could be x with the exclamation mark. So the first part of my problem is 15 factorial. So there it is. That huge number is the 15 times 14 times 13, etc. And I need to divide that by 3 factorial times 12 factorial. Now, it would be a good idea to use brackets here. So I'm opening a bracket. I'm taking 3 factorial, and I'm multiplying that by 12 factorial. Closing my bracket. Okay, I could say equals here if I want. And so this mess right here, 15 factorial divided by 3 factorial times 12 factorial, works out to be 455. I now have to multiply that by 0.1 raised to the power of 3. So 0.1, and I'm using my x to the y button here, 0.1 raised to the power of 3, and I'm also then going to multiply this by 0.9 raised to the power of 12. So 0.9 raised to the power of 12 equals, and here's my answer at 0.1285. So coming back in here, my answer works out to be 0.1285. So for this population, knowing that 10% are defective, basically there's a 12.85% chance that if we picked 15 items out of this population, 3 of them would be defective in some way.